Hello, folks, and welcome to Minerals, Rocks, and Fossil Talks. I'm your paleontology teacher, Jen. And today on Throwback Thursday, we're going to talk about Adam Sedgwick. And my cat is going to join us. Okay, in reality, we're going to be talking about three guys, but Adam Sedgwick is the primary one for this Throwback Thursday. So Adam Sedgwick here was a British geologist and an Anglican priest. Sedgwick would reinvent how we looked at geologic time. He was born in 1785 in Yorkshire to an Anglican vicar, and he went to the University of Cambridge for math and theology. How he ended up in geology after all that, I have no idea, but good for him. At some point, though, he did switch to geology, and he began to study the rocks of the British Isles and Europe, where he came up with a classification system for Cambrian rocks, as well as Carboniferous and Devonian rocks. In fact, he got involved in something called the Great Devonian Controversy. I'm in geology, and I didn't even know this existed. Then again, I work in Mesozoic rocks, which are much younger than Devonian rocks, so that's probably why. So this controversy starts with this guy, Henry de la Bec, or de la Beche is probably more correct, but he's English, so he probably pronounces his name wrong. Anyway, he had these plant fossils in a greywacke that he believed was older than the Carboniferous plant fossils also found in a greywacke. And don't worry about what a greywacke is, just know that it's a type of rock. But because he believed that they were different aged plants because one was found at a deeper depth than the other, he decided that trying to date rocks by fossils was not a valid method to use because of the depth difference. Just so you all know, the depth doesn't matter because we're finding things at the surface anyway, and things have been uplifted and flipped over and cracked and faulted and all kinds of messy things. The depth is not going to tell you anything other than a story about the structure, not about the deposition. So, it was a nice try. So what happened is then we had this guy, Roderick Murchison, who was like, Mr. LaBeche, you're doing it wrong, sir. That's not how this works. He believed that both fossils were near the top of the strata and that the depth didn't matter. That it was different, same system, different depositional environment kind of thing. Eventually, de la Beche agreed with him, but said there was still insufficient data because a red sandstone layer was missing from in between. Words of the wise. Yes, it's helpful when they all match like this, but you gotta learn to match them differently because guess what? You might not get a red sandstone deposited in an area where there's no way to get red sand. Shot, but it could still be the same age. Anyway, they were learning. I will forgive them. Sedgwick hopped in to help Mr. Murchison here, and the two actually found a similar layer in Russia, and thus the Devonian period was born. Basically, the Devonian was made to show that there was a difference between Carboniferous rocks and Silurian rocks, that there was something in between them. And they were right. Sedgwick also made some advancements with metamorphic rocks. He was the first to identify the difference between three different ways to get basically lines in your metamorphic rock. So the first is stratification. Now, these rocks that I'm showing you here are not metamorphic rocks. They are stratified sedimentary rocks, but you can get stratified metamorphic rocks too. So the idea is just to show you what I mean by stratification, and that's just literally depositional layering. So he got the difference between stratification, jointing, which are basically cracks in rocks that are caused from pressure. And so the rocks slide along fracture zones, or cleavage planes, various things like that. So these are actually physical cracks, not just lines. And the final thing he differentiated between those two was platy cleavage. So things like micas have a two-dimensional cleavage, and so you can peel them apart and they're like paper thin, and it's kind of cool. They have sheets silicates. We'll talk about that another time. But slaty cleavage comes from that structure that these sheet silicates have, and so that's different from jointing, which is different from stratification. And if you're interested in learning about either of those three, let me know in the comments and I will do a separate video for them. So hopefully you learned a little bit about the contributions that Adam Sedgwick and Roderick Murchison and even Henry de la Beche made to geology. And I will fossilize you later.